backwards at a speed of 15 meters per second. Now that means as soon as it leaves the person's hand, it's traveling at 15 meters per second. So we're not worried about the period of time where the person's hand was accelerating, speeding it up. So it started at rest, left at 15 meters per second. We're not worried about that part of the time. All we care about now is that it's in the air, it's moving at 15 meters per second. I'd like to find out how high it goes. So here's our ball. You might find it helpful to draw a little sketch of what's going on. Here's our ball. It's going to go up until it reaches some maximum height. That's what we want to know. Now, keep in mind, we are not at this point in time going to worry about air resistance. Drag, air resistance would slow the ball down, yes. We're not going to worry about that yet because it's very complicated to take air resistance into consideration. Air resistance depends on how fast your object's moving, it depends upon how aerodynamic the object is, it depends upon the density of air, which depends upon the temperature of the air, and the humidity of the air, and the altitude that you're at. Air resistance is really hard to work with, so we're not going to worry about it right now. We need practice dealing with just the basics. So, no drag, no air resistance. We'll pretend we're on the moon. Except for we have the gravity of the Earth. That was a bad example, sorry. Okay, I recommend when you're solving these types of problems, write down these variables. So x naught, x, v naught, v, a, t, and fill in the ones you know. Because that's going to help you choose which equation to use. Now, x naught. In every problem that we do with motion, we need to choose an origin. Turns out it doesn't matter where you put the origin as long as you keep it there for the whole problem. Once you choose your origin, that's your origin. You can choose it wherever you want to be, though. So I want to go ahead and say my origin is right here. So what can you tell me about my initial position?
0.
0. My final position is what I want. That's what we're looking for. How high does it go? This x value up here. Initial velocity. 15 meters per second. Final velocity.
0.
0. Acceleration.
Negative 9.8.
Negative 9.8 meters per second squared. Fabulous. Acceleration of gravity. Time we don't know. But look, we know quite a bit. We don't know x, we don't know time. We're looking for x. So, looking at the equations we have available, acceleration's constant, so we know we can use them. All of these equations, we want the one that has x and no time. The bottom one. So v squared is equal to v naught squared plus 2a x minus x naught. V final is 0. Initial position is 0. So bringing this to the other side, we get negative v naught squared is equal to 2ax. So x will be equal to negative v naught squared over 2a. That negative sign isn't part of the squared, so you're not squaring that negative sign. So negative 15 meters per second is our initial velocity. We need to square that. All over 2, our acceleration was negative 9.8 meters per second squared. The negative signs are going to cancel. So x will equal 15 squared over 2 times 9.8. Now, I get 11.497, blah, 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 blah. A lot of decimal places. We should technically have 2 significant figures, so 11. If you want to write 3, 11.5 would be fine. Meters are our units. The second squareds cancel. 1 of the meters cancels with 1 of the meters in the meter squared. So our units are meters. So this ball will travel 11 meters into the air. And it's good to see if this makes at least somewhat sort of sense. We get a positive answer. Does it make sense to have a positive answer? Our ball ends up above our origin, so yes, positive is good. 11 meters, not too far. Seems okay. What will the velocity of the ball be as it continues on its way back down right before it lands in the kid's hand or the person's hand?
The velocity?
The velocity.
So we got 11 meters time.
Now, I'm assuming that the person's hand is at the same height as it was when they let go of the ball. So they're going to catch it at the same height. So what is the velocity of the ball as it lands back in the person's hand? Same approach. We can do this 2 ways. We can go ahead and call right as it leaves the person's hand initial still, and then final right before it lands in the person's hand. That's fine. Or if you want, we can now call the highest point initial and then the final point right before it lands in the person's hand. Doesn't matter. You can use either way. Which do you want to do?
Top initial.
Top being initial? Okay. We're going to have a new set of values here then. So same approach. Let's look at the variables that are in the equations and figure out what we know. What will the initial position be if this is initial up here now?
11.
Positive 11 meters. We're above, 11 meters above. What will the final position be? 0, because it's getting back to the person's hand, which we're saying is the same height as it was when they let go of the ball. What's the initial velocity?
0.
Final velocity is what we're looking for. What's the acceleration?
Negative 9.8.
Negative 9.8 meters per second squared. Again, no air resistance, no drag. We still don't know the time. So with that information, we want one of the equations that has v in it and all this other stuff, and not time again.
Bottom one.
Same equation again. That's kind of boring. Oh well. So initial velocity is 0. And final position is 0. So v squared is equal to 2a times negative x naught. So v will be the square root of negative 2a x naught. A is negative 9.8 meters per second squared. X naught is 11 meters. So the negative signs cancel again, which is good since we don't want to end up with imaginary numbers. We're not going to do anything imaginary in this lab in terms of numbers. So, interestingly enough, we get 15 meters per second. There's a slight problem with my answer though. Can anyone see what it might be? It's negative. When we take the square root, yes, you got your plus or minus option. You need to choose the appropriate one. Minus is appropriate. The ball's headed down, back towards the person's hand. So the final velocity as it hits the person's hand is negative 15 meters per second. Which, interestingly enough, the speed of the ball when it left the person's hand was 15 meters per second. Does it make sense that it would be 15 meters per second by the time it came back? It slows down by 9.8 meters per second every second on the way up. It's going to speed up by 9.8 meters per second every second on the way down. The acceleration up's the same as the acceleration down. In the same amount of distance, same amount of time, it should reach the same speed. Exactly. Okay?
How are you getting rid of one of the seconds?
Square root.
11 meters and 9
So you end up with meters squared over seconds squared. Once you square root it, you get meters per second. Okay. Good to watch your units. It's really good to do that. Because if you don't get the right units, you certainly don't get the right answer.